Welcome to Activity 3.1, Objects that Begin Moving. The learning target for today is we're going to use models to figure out whether and how a system begins to move. And my expectation for you is that you're going to develop an interaction table. So we've developed and we've completed interaction tables in the past, and complete force models for the tennis ball and the marble movement. So you're not actually in class, but what I did in class and what you're going to have to be able to interpret is that it says your teacher demonstrated two simple instances of objects beginning to move. A tennis ball that was tapped. So I had a tennis ball and I tapped it and it rolled across the table. So imagine that. Then it says there's a marble that was shot out by a stretched rubber band. So I had a rubber band, I stretched out. I didn't fire it too hard because I didn't want it to break or I didn't want it to hit anybody. But on my lab table in the front, I had a rubber band, I stretched it out, and I shot the rubber band, or I shot the marble out of the rubber band. So in both instances, they both started to move. So what I need you to do for procedure number 1 on page 25 is you need to write a single explanation that is good for both objects. So explain why the objects began to move. Why did the tennis ball begin to move? Why did the marble begin to move? Now, your response, again, needs to be good for both. And here it says your response needs to work for both scenarios and not be specific only to the tennis ball or only to the marble. And the reason why is in physics, it's essential, or in science anyway, it's essential that explanations can be generalized and can cover multiple possibilities and are not specific to a single case. So how the rubber band or how the marble started moving is going to be very similar to how the tennis ball began moving. Would be very similar to how a basketball maybe began moving, a pool ball. So all these different things, it's going to be the same. And you can't have 1,001 generalizations saying, oh, this is specifically for a tennis ball. This is specifically for a marble. So I'm going to be quiet and I'm going to let you answer this. Write a single explanation, just a sentence or two, that would explain why the objects began to move. So go ahead, pause the video and do that. All right, now that you've had a chance to do that, again, they give you a lot of room on page 25. I don't expect you to fill the whole thing up. Let's flip the page over to page 26. Now, on top of page 26, it says, using what you learned in lesson 2, make an interaction table showing all the interactions involved in both cases, and then draw models that show the various components of each system and the forces that act on them and that they apply. So you're going to create 2 interaction tables. Now remember, this is what an interaction table looks like. So this would be for the tennis ball. So what you'd have to do is up here, you'd have to label each component of the one with the tennis ball, the one where I tapped it. So let me help you out. You had the ball, you had the table, I tapped it with my hand. Remember, the earth is going to represent gravity. So what I need you to do is create one of these on page 26. Now make it small enough because you're going to have to put another one on there for the marble. So in here you'd put a plus if they interacted. So did the ball interact with the table? Yes. Did the ball interact with the hand? Yes, it would be a plus sign. Did the ball interact with the earth or gravity? Yes. However, when you get to this one right here, did the table interact with the hand? Did it? No, unless my hand's resting on the table. If I tapped it and my hand wasn't resting on the table, there is no interaction. So no, you'd have a minus sign here. So go ahead and fill this in. Now, let's create the next interaction table for the marble. So you had the marble, you had the table, you had the rubber band, and you had the earth. So go ahead and fill in the pluses and the minuses. Pluses if they interact, minus if they do not interact. So now that you've had a chance to do this, and again, pause the video and complete this. All right, so now that you've finished this, the reason why the interaction table is important, because wherever you have a plus, you're going to have forces being drawn on your model. Wherever you have a minus, you won't have forces because there is no interaction. So next thing I need you to do right below those is to draw me force models for the tennis ball components and the marble components. So go ahead, pause the video, and draw these again. Now that you've had a chance to draw them, how do they look? Again, they can be basic shapes. They can be basic circles, basic squares. And did you draw in all the forces? Did all the forces come in pairs? So if the tennis ball is pushing on a table, the table is pushing back. So are they in pairs? Are contact forces solid lines in your models? Did you draw non-contact forces as dashed lines? So here's what your models might look like. How did you do? Did you do all right? You might say, okay, with this one, why didn't you have the hand, Mr. Attune? If you had the rubber band in the hand, and the rubber band, well, it's because the hand really didn't touch the marble at all. It wasn't used. It was just used there to prop up or to hold the rubber band so I could hit the marble or use the elastic energy to get the marble to start moving. So now that you've done this, there is questions 3, 4, and 5 on the page 26. So go ahead and complete those. How'd you do for those? So what did you say that the 3 forces that act on each object were? Did you say the pull of gravity, the push of the table, which is a contact force, and the force due to the hand or the rubber band, so which would be another contact force? So we had at a distance forces and 2 contact forces. Which of these forces act horizontally? Well, the push of the hand and the push of the rubber band act horizontally. The pull of gravity and the push of the table acted vertically. So this is important because pretty soon we're going to start to figure out that horizontal forces cause things to move horizontally. Vertical forces cause things to move vertically. So you can't have a horizontal push cause something to move up and down vertically. So being able to answer that question is pretty important. Then the last one, which of these forces can cause each object to begin moving? Well, the objects began moving horizontally. Oop, we don't quite see the bottom of this, but it says the objects began moving horizontally. So it took a horizontal force to cause the ball and the marble to move horizontally. They didn't move vertically because it would take a vertical force to cause them to move vertically. So let's add a couple scientific principles here. The beginning of motion is always caused by unbalanced or unequal forces. If forces are equal, there's going to be no motion involved, or nothing can cause them to move. So go ahead and add that to the front of your book. And as always, if you have any questions about anything we did, anything about the model, anything you want to talk about, be sure to ask your science teacher. Thanks.